Hello everyone, today we will start with PZX numericals, basic terms you need to know before you solve and how to solve those numericals. So before we proceed with the numericals, we need to understand the basic terms because solving these numericals there are two important things you should be aware of first. First being you should be clear with the basics, you need to know all these terms, and the second you should be able to draw the correct diagram, because unless you have the correct diagram you won't be able to solve the sums properly. So we will first look into these terms and then I'll explain you how to draw these diagrams. Once we are done with it, then we will proceed in solving the numericals. So I will explain it to you with respect to the diagrams. I will show it on the diagrams. What does prime vertical, vertical circle, observer zenith, rational horizon, zenith distance, declination, amplitude, azimuth, and true altitude means. So let's start. Okay, let us consider that the observer is in latitude 10 degrees north. So in a normal diagram, how we will donate is, say this is north, east, south and west, and this is equator. Then this latitude will be 10 degrees north, right? So let us consider the observer is here and this is the observer's meridian. So this point will be zenith. Now what we do is, to complete this diagram properly on the equinoctial, we will tilt the earth towards ourselves such that the tilt will be approximately equal to this. So this much should be the tilt. So accordingly the north pole will also shift downwards. So the equinoctial or the equator will come down by the same amount. This should be equal to this distance. Okay, and similarly the north pole will be here, so this distance should also be equal to this tilt. Now the observer is here, so this is the observer's zenith, and so we denote it as Z. The others remain same: north direction, south direction, east and west. And this is the equator, okay, and this is 10 degrees north. Similarly, if the observers, for example, is in 10 degrees south, so the diagram will be, so this is equator, this is north, this is south, east and west. So the 10 degrees south will be here. Similarly, if I draw it here, I'll have to incline the earth from south pole, tilt the earth from the south pole. So the equator will be a curved line, and here is the observer. This is the observer. This is observer's meridian. Okay, similarly here this is the observer's meridian, and this is the zenith of the observer, so we denote it as Z. The directions will be same. This is north, this is south, east and west. This is equator. Okay, now in this diagram also the tilt will be equal to this, so this is the tilt, same will be this. Okay, this will be the tilt and this will be the south pole. Okay, with reference to south pole, so this distance will also be equal to this tilt. Okay, I hope this is clear to you. Now we only considered with respect to observer. Now what if we introduce a body like sun, stars, planets? Okay, so now let's see what happens with respect to a body. Now let us consider that the observer is in 45 degrees north and the declination of the sun is 20 degrees north. So first let us consider where will be this on a plain normal diagram. So this is equator. Okay, So north, south, this is east, and this is west. Now 45 degree will be somewhere in between this mark and this mark. So let us consider it is here. So I draw this latitude as 45 degrees north, and this being observer's meridian, and this latitude of observer. So here is the observer. Okay, this is the observer. Now it is 20 degrees north, so it is somewhere between 45 degrees north and equator. So let us consider it is this mark. Now this is the declination. Okay, this is declination of the sun. So what will happen is, let us draw this now on the sphere. First naming the diagrams north, south, east and west. Now we tilt the earth, since the observer is in the north pole, we tilt the north pole towards us. So this becomes the equinoctial. Okay, let me redraw it. It is 45, the observer is 45 degrees north. So 45 degrees north will be in between this and this. So it comes somewhere here. So this is the equinoctial or the equator. Okay, so this becomes the latitude of the observer, which is 45 degrees north, and we have to draw declination of the sun, that is 20 degrees north. So if this is equator, 0 degrees, and this is 45 degrees, so in between this it will be the observer's, sorry, latitude, declination of the sun. So if this is 0 degrees, this is 0 degrees, and this is 45 degrees, so we consider this as to be 20 degrees. Okay, this mark we consider as 20 degrees north. So I draw a curve similar, this line I draw it over here, so it will be something like this. So this is the declination of the sun. I hope this much is clear. So what happens is, the sun rises from this point over here, okay, from east. It will travel on this line, it will pass the observer's meridian over here, this is the observer's meridian. It will pass here, and then again it will proceed on this line and set here in west. Okay, now let me explain you in a 3D diagram all those definitions and what we studied earlier, what actually happens. Now what we discussed earlier was, this is the observer. Okay, this is the observer. Vertically above the observer is his zenith point, okay, what we denoted as Z. Now this is the horizon. Now true altitude and everything is calculated from rational horizon, which is the plane passing through the center of the earth. Now for reference, let us consider this is as horizon, a rational horizon. Okay, now the directions are denoted north, east, okay, west, and this is south. Now what is azimuth and what is zenith distance, what is true altitude? Let me show you. True azimuth is measured from north towards the body. Now you see this blue purple line, this is the declination. Okay, this is the declination. So the sun rises from the east. Okay, the sun rises from the east direction, so this is the body. Okay, sun rises from the east direction. Now this body, if I measure from north direction, the point where I get the bearing, the azimuth, sorry, the azimuth of the body is the true azimuth. Now if you see this green line on the aft, this is the green line, this is the azimuth of the body. Okay, now in this diagram, the latitude of the observer, like what we considered in the diagram, consider it as the latitude of the observer as 45 degrees and declination of the sun as 10 degrees north. Okay, so this is what it happens. So the body will rise here, it will attain the maximum altitude when it is on the observer's meridian, that is this mark. Okay, it will be here on the observer's meridian, and then again it will start falling down, that is the altitude of the body will reduce and it will ultimately set in the west direction. Okay, the same diagram when it is in the meridian passage I have showed you here, you observe this when it is on the meridian passage. This is when the body will have its maximum altitude. Okay, now what is zenith distance? If you see, this is from zenith distance until the horizon is 90 degree. Okay, this angle is 90 degree. Now true altitude is from the rational horizon towards the center, to the center of the body. Now this angle is called true altitude. Okay, this angle is true altitude. So the remaining what we see here is called zenith distance. The similar is marked here on the diagram. You can pause the video to understand this diagram. Since I am making these markings to explain it to you, you can pause the video and you understand the diagram and the markings made. It is this diagram is very helpful in understanding this. Okay, now what I have to explain to you is prime vertical and vertical circle. Prime vertical is vertical circle, okay, passing through east and west points of the rational horizon, and vertical circle is great circle on the celestial pass, okay, great circle on the celestial sphere passing through the observer's zenith and the nadir. Now if I draw a circle, let me show you on this diagram. If I draw a circle, it passing through the observer's zenith, that is this point, something like this, then going behind and again coming up, this is a great circle passing through the center of the earth and observer's zenith and the nadir, is called vertical circle. Okay, what is prime vertical? Prime vertical is a vertical circle. I repeat it to you again. Prime vertical is a vertical circle only, but it passes through the observer's east and west direction. So this will be passing from east like this, from the observer's zenith and to the west. That means, let me show you once again. If I draw this diagram like this, from east to west and also passing through the observer's zenith and the nadir. So from the bottom like this. I hope you are understanding this clearly. This is the blue line what I have drawn right now is called prime vertical. Now in this diagram, the latitude of the observer is same or equal to the declination of the body. So if you refer, I would request you to pause the video and carefully understand this diagram. Here the first diagram, the body is before the meridian passage, and hence the green denotes zenith distance and the orange denotes the true altitude, that is after a few hours after the sunrise. And the next diagram is the body at meridian passage, where the body is at the zenith, that is vertically top of the observer. I again request you to pause the video and carefully understand these diagrams. Now to solve these PZX triangles, we need to know two important formulas. One is called the Napier's formula and the second is cosine formula. Cosine formula is very rarely required. We will be mostly using the Napier's formula. Now to understand that, let us draw a diagram and understand it first. We consider that latitude is
45 degrees, same north, and declination of the body is 20 degrees north. So this is the latitude of the body and this will be the declination. Okay, so this is zenith, this is east, this is west, north, south, and this is pole. Now let us consider that the body is on the horizon. So px, what is px? Px is 90 minus declination. Then what is pz? Pz is zenith distance, so that will be sorry, the pz is colat, so that will be 90 minus latitude. Zx is zenith distance, okay, so that will be 90 minus true altitude. Okay, now in this diagram, since the body is just on the horizon, your zx will be 90. For Napier's formula, you have two conditions: either one angle should be 90 degree or one side should be 90 degree. So you can, so in that time only we will be able to use Napier's formula. Now what we have is side zx is 90 degree. We may also have a condition where you have a body. Let us consider this example where latitude is 63 degree, latitude is 45 degree, and the declination is 63 degrees Celsius. Okay, so let us consider that the body has a maximum azimuth. So let us consider here is the body with a maximum azimuth, so this becomes px, this becomes zx, p north, east, south, and west. Now this angle here will become 90 degree. Now how this become 90 degree? Suppose this is a circle and I draw a tangent to this circle. I draw a tangent to this circle. So from the center of this circle, if I draw a line, this angle is 90 degree. Similarly, this angle becomes 90 degree. Now I have shown you these two cases where one angle or one side becomes 90 degree. The important part in solving the PZX question is first to understand whether if you have a 90 degree angle or a side. If any one of this is missing or both of them are missing, then you will go to cosine formula, which is very rarely required in solving these questions. Okay, now what does this formula do? How to use this Napier's formula? Now let us consider this diagram first, wherein we have an angle of 90 degree. So I'm drawing this diagram again. Okay, this is the diagram P, Z and X, this angle being 90 degree. Now you will have to draw a circle, okay, and divide it in such a way. Now angle X is 90, so you write angle X as 90, and since angle X is 90, you write the side adjacent to angle X in these first two columns, first two part of the circle. So that will be Px and Zx. You can write it anywhere, either way, no issues. Now you once you write this in these columns, you will have to write 90 minus whatever angle you have. Now what happens is, you in this column, in this section of the circle, you write what is the angle opposite to Zx. Okay, so now Zx is this, okay, this side. So the angle opposite to Zx is angle P, so you write 90 minus P. Similarly, in this section you write what is opposite to px, side px. So this is px and opposite to px is angle z, so you write 90 minus z. Now what will you write in the remaining part in this section is the remaining angle or the side opposite to angle x. So the side opposite to angle x is pz, so you write 90 minus pz. Okay, Now you have this diagram, which is very important. On this diagram we will solve the sums. Now to remember the Napier's formula, it is sine of mid part is equal to cos opposite cos opposite. You just remember this formula. I will uh, inform you how to, or I will teach you how to consider this opposite side or mid part. Okay. Now again, sine of mid part, there are two formulas. Sine of mid part is equal to tan adjacent into tan adjacent. This adjacent is adjacent side. Now I will explain it to you, these what is cos opposite and tan adjacent while we are solving the numericals. Okay, I hope this until now is very well clear. Now what we are left is with cosine formula. Cosine formula is very well easy. It, you'll just have to remember the formula. Now we will take the same diagram where this angle is not 90 degree. Okay, so what we can do is PZX. Now let us consider we want angle P. So what we do, we write cos of capital P. Now here we will denote sides with small letters and angle with capital. So angle will be this angle X, angle P and angle Z, and side opposite to angle P will be small p. Okay, side opposite to angle Z will be small z, and side opposite to angle Z will be small x. So the formula is such that cos of P is equal to cos of small p minus cos of x into cos of Z divided by sine of x into sine of Z. This will be similar for all angles. So how to write this formula? You write whichever angle you get first, like cos of P. So you write cos of small p minus the remaining two sides divided by sine of, it will be, this will be same, instead of cos you write sine. I hope you have understood until now. Let us solve a sum so that you can have a clear idea. If you have any questions, kindly mention them in the comment section below. Okay, let us solve this question. Find the maximum azimuth of a star of declination 66 degrees 47 minutes south for an observer in latitude 43 degrees 39 minutes south. Okay, so we need to draw the diagram first. So as per the question, the observer latitude is 43 degrees and 39 minutes south, and declination of star is 66 degrees 47 minutes south. So as since the observer is in southern latitude, we'll have to tilt the south pole, and the observer's latitude is 43 degrees. So let us consider this should be half of 45, so approximately 45 degrees. So this becomes equator. North, east, south, west, this becomes zenith. Okay, this point, and this becomes the south pole. Okay, now I'll have to draw declination of the star. So the declination of the star will be 66 degrees. That will be somewhat like this. Draw fair line. Okay, now the maximum azimuth, it is, it can happen that the maximum azimuth will be reached after the sun has risen, and after crossing the observer's meridian again there will be a maximum azimuth reach, and then the star will set. So what we will do, we will first consider on one side. Okay, so let us say that the observer's maximum azimuth will be here on this side. When will be the maximum azimuth? Now let us understand that if a star is rising, now let us consider this is pole, this is observer's meridian, and this is zenith, and this is the declination. What will happen is, this is the inferior meridian, so the body will rise, as in it will pass the observer's inferior meridian, it will gain the maximum azimuth is over here. Okay, for example, if the body is over here, the azimuth will be, for example, 010 degrees, it will be 020 degrees, 0300 degrees, 03, and so on. So it will reach the maximum azimuth, and again it will start reducing. Okay, and then again it will go on the other side, it will reach the maximum azimuth, and then again it will start reducing. So this is the logic. So if I draw a tangent to this point, and if I join this line, this will be 90 degrees, because this will be 90 degrees, as any point any tangent to the circle is 90 degree to the radius, right? That's the logic. So let us consider in our diagram, I'll erase this off. Okay, in our diagram, let me join our z, that is the zenith of the observer and the body, and let me join P and the body, so this becomes 90 degree, and here we have our PZX triangle. So I will draw this PZX triangle a little big one, so that we have clear understanding. Okay, now this is Z, this is P, and this is X, this is 90 degree. Now as explained earlier, we have an angle that is 90 degree, so we will draw this diagram to help us solve with the Napier's rule. Okay, now we have angle X which is equal to 90 degrees. Now the sides adjacent to angle X is PX and ZX. So PX will have to so in this column, in this section, we'll have to write what is opposite to PX. So opposite to PX is angle Z. Okay, angle Z, this one. So what we write is 90 minus Z, and opposite to ZX will come on this side. So opposite to ZX is angle P over here. So we write 90 minus P, and in the middle will be side opposite to angle X, that is this one, ZP. So we write 90 minus ZP. So we have everything right now. Now what we need to calculate is, and understand in the diagram. Okay, let us understand what all information we have from the diagram. Now what is PX, this one in the diagram? Okay, let us see here. What is PX in the diagram? PX is 90 minus declination. Okay, remember this. So we have PX. If I minus this is let me explain it to you here. Now from pole to the equinoctial is 90 degrees, right? So this is the declination, this much is the declination, right? So 90 minus this declination, I'll get PX, that is what I have written here. Now what is ZP? ZP or PZ is colat. Okay, so it will be also same, like from equator to pole is 90 degrees, and this is latitude, right? So 90 minus latitude is colat, so we have PZ also. Okay, and this is angle Z, this is azimuth, right? Azimuth, we have to find this angle, the maximum azimuth. So coming back to the solution, now what all do we have? We have PX. Okay, we have found it here. If you can see, we have found the PX. Then we have ZP or PZ. Okay, we have the second value, we have this, and we have to find out angle Z. Okay, so what we will do, we will use Px. Okay, so as per the formula, Napier's formula, what we have, sine of mid part. Okay, I'll write the formula first. Sine of mid part is equal to cos opposite and into cos opposite. Now, why I am using this formula, we have another formula also, like sine mid part is equal to tan adjacent, tan adjacent. When I will be using tan adjacent, when I know P and ZX, and I have to find either of it. Now what happens is, I am considering PX and I have two opposite options available and I have to find Z. I know two known options, okay, PX and ZP, and Z is unknown, but which is opposite to PX, so I am using opposite, cos opposite, cos opposite. Okay, now sine of mid part is sine of PX is equal to cos of opposite, which is 90 minus ZP into cos of 90 minus Z. Okay, now you need to remember two things. Cos of 90 minus theta, theta is in whichever angle you want, is equal to sine of theta. Okay, you remember this formula. So what I will do in this formula is, sine px, I'll keep it as it is, cos of 90 minus zp, cos of 90 minus zp will, now 90 minus zp, what will happen is, I'll just rearrange this formula. Okay, rearrange this. So what we had written is 90 minus pz is equal to 90 minus lat. So what I'll do is, I'll just write it as latitude is equal to 90 minus pz, or whatever, 90 minus zp. So you get latitude. Now what we have in this is 90 minus zp. So I'll, instead of 90 minus zp, I'll write cos of latitude. Okay, from here it is one and the same. And instead of cos of 90 minus z, instead of this one, I'll write sine theta, like, because cos of 90 minus theta is sine theta. So what I'll write is sine of z. Okay, now we will input the values. Sine of px, so sine of px is 23 degrees. Px, you will get it like 90 minus declination. If you do, you will get 23 degrees 13 minutes. And cos of latitude, that is 43 degrees 39 minutes. And sine of z, which we have to find out. So sine of z is equal to sine of 23 degrees 13 minutes divided by cos of 43 degrees 39 minutes. So you get 0.5448. This is sine of z. Now what you have to do is just do sine inverse of this value. You get 33.01 degrees, and if you convert it to degrees and minutes, it is 33 degrees 01.7 minutes. Now like I said earlier, we have considered only on one side, that is east. So this azimuth is 33 degrees 0.7 minutes south and east, but there is a possibility that it may come on the setting side also. So during the solution, you'll have to write south 33 degrees 0.7 minutes west also. I hope that is clear. We will be solving few more numericals in our next video. Kindly stay tuned. Thank you. Keep watching.